Hello, welcome to Z Talk. How are you guys doing? In this session, I'd like to continue to talk about Terraform. In the previous couple of sessions of Terraform, we went through deployment automation on AWS components like EC2 instances, VPC, S3, auto scaling, IAM, and etc. Right? Um, in each of my demos, as remember, the problem was if I wanted to reuse a piece of code from a previous demo to the new session, I had to copy the code base from project to project, which is really tedious and completely unnecessary. It's inefficient, right? To improve the code reusability, Terraform actually comes up with a concept called module. So the topic of this session will be around Terraform modules. All right, cool. Stay tuned. Let's start with a common use case. Consider we have a Terraform config structure like this in the left side of the slide. We are working on multiple environments. Now, if we needed to define a new resource in dev environment, and this resource will create a new, for example, a new elastic cache. So normally what we were gonna do is to create a resource definition within main.tf file in the dev directory. And then we're gonna copy it across other environments, right? That's basically what I did in the previous demos. Um, Consider this specific scenario only involves one resource. I'm kind of okay with it. However, what if there are hundreds of resources need to be created in your infrastructure? What are you going to do about it? Apparently, copy and paste is not a viable option anymore, right? We needed a solution so that where we can define resources once for all, and these resources can be used anywhere whenever they're required to be consumed. The solution is Terraform modules. Terraform modules provide reusable code. Users can add code inside of a Terraform module and reuse that module in different places. Modules are the key ingredients for writing reusable, maintainable, and testable Terraform code. The way of creating module is very simple. Just create a directory that hosts a bunch of .tf Terraform config files. Whenever we needed to refer that module, we just simply refer it with the help of the source directory. Here example, on the right side of the slide, we create a module and we just refer that module with a source directory like this. It's kind of similar to functions in programming languages. Modules are reusable codes that can be invoked multiple times with different inputs. All right. Now that users have the modules in place, there is another issue might comes into the picture. For example, the same use case of elastic cache, we might just need a small cache node in the elastic cache cluster for testing in dev environment. On the other hand, we need multiple large nodes in the cluster for prod. It's pretty common, right? So to make that happen, we will make the resources configurable with the help of variables. Here is the structure looks like here. Variables.tf will hold the variables that configure the module, and resources value inside each of main.tf configuration file will be called from variables.tf. Initially, variables.tf contains the default value, and going forward, we can overwrite those default values in different environment directories as needed per our requirement. All right. This exactly fixes the issue in the use case where dev environment requires only a small elastic cache node, and prod requires multiple large nodes, right? All right. Next question, what do we get those modules? Of course, we can create our own modules from scratch, but there are actually plenty of handy modules that were created by developers already shared in public repositories like GitHub. You can use them directly. Another source of modules is Terraform registry. And the third source of modules is of course like I said, we can build our own modules from scratch. So it will be on our local file. We just create and store it on local, and refer that local that location from our local when as needed. All right, cool. That's pretty much it. Let's quickly jump to the demo session. In the demo session, I will show you quickly first how do we call or refer a module that was created by other developers on GitHub. I'll show you how to call that, and then I will show you another demo to create our own demo from scratch. All right. Before I jump to the demo, just again remember to sum up if you think this session is helpful, and subscribe my channel if you haven't done so, and of course leave any comments if you have questions. All right, cool. All right. If you search for Terraform AWS modules on GitHub, you will see a bunch of modules out there. Here example, it's a module for AWS EC2 instance. I would use I'll just use this guy as an example to show you how do we refer it for our use case. But let's take a look at the key config files inside of these modules first, right? Let's start with main.tf. Let's go inside of main.tf. As you can see, it's a kind of big file, and as you can see, the majority of the values have been variabilized here, right? And the default value or the variables were defined in the other file, which is variables.tf. Let's go back and jump to variables.tf. And as you can see, all those variables were defined, and some of the variables provide a default value like this instance count. The default value was 1. So let's leave it there. And the other variable like name, and there was no default value provided. That's actually what we're gonna do next. We're gonna create our config file, and what we're gonna do is to override or set the values for those variables based on our own requirements. All right, cool. So here, go back to the main page. So again, so for referring these specific module, what we need to do is we need to get the path of this module. Here we go. Let's just copy this whole thing, HTTP protocol, or the address, of these module, copy that, and let's jump to our Visual Studio Code. Here I created a main.tf file. So here I create a module called EC2 cluster, and I'm just gonna copy paste the source that and that we copy from GitHub. Here we go. And remember, remove the HTTPS / the protocol in front of the URL. All right, so that's pretty much it. And then what we're gonna do next is we're gonna set the values for those variables inside of the variable.tf here. Like the first variable name, there was no default value being provided. So what we need to do in our config file, in our own main.tf, we need to give a value for that specific variable, like name. And for AMI, so let's jump to AWS console. Besides the main.tf, I also gonna need a provider.tf where I just need to define the private key, access key for my AWS account and the region. All right, so I'm gonna deploy these instance in region US East 1. So let's quickly, to make this demo really simple, I just quickly jump to the AWS console, and here I'm on US East 1, and here in the VPC you can see the subnet. Let's grab a subnet for within this VPC subnet. We'll just use the random subnet. How about this guy? So copy this and put over here. Subnet ID, and give it a couple of tags. This is optional, and the instance type gonna be T2 micro, and I'll get a AMI that is available in US East 1. So let me go back to the previous page, and let's click launch EC2 instance. Just randomly grab a AMI. So how about this guy? So for a Amazon Linux 2 AMI. So I will just copy this AMI ID and paste right here. All right, that's pretty much it. So save it and go to the provider.tf. Remember, for your case, you're gonna put the access key, secret key down here. Put value down here, and then we're good to go. All right. So save this file and just issue Terraform init and then Terraform apply to see how it goes. All right. All right. As you can see, I've added my own access key and secret key inside of these provider.tf. One note here, as we know, these access key and secret key both are sensitive security information, private information that we do not want to share with others. Otherwise, it's going to be a serious security violation. That's pretty much why I had to break it off to a separate config file provider.tf instead of just configure the same way as the other variables. Because if I do the same like other variables, these string, the access key and secret key string, will be exposed as a plain text in the main.tf. And if we upload or code to or a GitHub repo, everyone can see our access key and secret key. because that's definitely a security violation that should not happen ever, right? So that's basically why I created provider, because if I create a provider, I can add these provider.tf in the GitHub ignore file, so that it prevents this specific provider.tf from being uploaded to GitHub repository. So it will be stored local, on our local. And another option is we can just expose or export these access key and secret key as a environmental variable. In that case, we don't have to define inside of these config file. We just export it and then we can run that. That's another option. Both should work. All right. Okay. So let's jump to our command line, and we got everything ready. So let's issue a so here let's issue a Terraform init, and then let's do a Terraform apply to see how it goes. Okay. Sorry, Terraform apply. And yeah. All right, it's done. As you can see, one resource was created, right? So let's jump to AWS console to verify. Here we go, and you can see there's an EC2 instance up and running, and the instance name is exactly what I defined in the main.tf my cluster, right? Visual Studio Code. Here we go, my cluster. All right, cool. Let's jump to the second demo. All right, let's moving forward to the second demo. In this demo, I'm gonna create a module for creating custom VPC from scratch. And to reproduce the use case I brought up in the presentation in the beginning of the session, I will be working on two environments as a use case, dev and QA. So which means I'm gonna need to create two custom VPCs for the two environments separately, right? So let's first take a look at the vpc.tf, which is the main configuration file. Here, by the way, I created a new folder for this demo called Terraform_module_local, right? And I create the vpc Terraform.tf. Inside of this file is pretty simple. I just define the AWS VPC resource. As we've already had a session for VPC specifically, I'm not going to go through each line here. Just go review Terraform registry documentation for AWS VPC if you need some reference regarding the configuration of this resource, right? So in short, these are the configuration required, and as you can see, I variabilize each value, just similar like the previous module did, right? So, and then I define the variable inside of the variables.tf file, right? Okay, as I said, I'm gonna need to create two custom VPCs for two environments, QA and dev, respectively, right? Here's what I did. As you can see, I create two directories for hosting the configuration files for each environment, like dev and QA. And inside of these two folders, I create a main.tf configuration file to store the value of or to store the configuration specifically for these environments. And as you can see inside of the main.tf, instead of defining the AWS VPC resource, I just defined a module called QA VPC and dev VPC, and inside the module I referred the the module I just created, which is, see here, the resource, which the resource were pointed to the TF module and it's for a local directory here. Basically, I am gonna refer these module I just created, right? So same thing, I need to assign the value for each of the variables here. So for each of the attribute here, like VPC, give a VPC name, give a site, assign a CIDR for these custom VPC, something like that. And same thing for QA, and give another CIDR name and another VPC name. That's pretty much it. And then let's do a Terraform apply and to see how it goes. All right, cool. So let's jump to here, Terraform local. Let's do a Terraform init. And then let's do a Terraform apply. All right, as you can see, the custom VPC has been created for dev. I'm in dev folder, right? So here one resource was added. Let's jump back to the Visual Studio Code, review the main.tf for dev. As you can see, inside of this module, I did not define the regions, which means it's going to use the default value. Here, the default region is US East 1. So let's jump to AWS console and go to US East 1 and VPC, and here we go. You can see a custom VPC was created right here, and if you check the CIDR, which is exactly what we defined, 10.0.2.0, right? And Visual Studio Code main.tf 10.0.2.0, right? And the VPC tag, we added dev and dev0-vpc. Here, click tag, dev and dev0-vpc, right? Same thing for QA, and let's run the same thing for QA. So QA here, I'm gonna override the region instead of the US East 1 this time. The VPC will be built in the US West 1 region, and the CIDR is 10.0.3.0. Let's go jump to the terminal and go to the QA folder, and let's issue a Terraform apply. Yes. Okay, and it's done as well, and one resource was added. So let's jump to AWS console, go to West 1 region, and go to VPC, and here we go. This is the custom VPC we created for QA environments, and you can see the CIDR is 10.0.3.0, which is exactly what we defined, right? And the tag environment is QA, and name of these VPC is QA01 VPC. All right, that's pretty much what I want to show you for this session regarding Terraform modules. Let's call it a day, and thanks for watching, and I will see you next week.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.